so I'm gonna finish the end of the notes from last class. And today we're gonna see some applications. So actually now should be getting more exciting, the class, right? We're gonna run some experiments and see things happening, and we're gonna make measurements and make predictions and things like that. Is that okay? So let me go over these two equations here, and the relation that is missing is this one, is the difference between the squares of the velocity and equal to A, and then the difference between the distance, right? 2 times the acceleration times the distance is equal to the difference between the square of the initial velocity and final velocity. So let's try to find this one by solving these two equations. So here I have the velocity as a function of time, okay? And here I have the distance as a function of time, okay? So what I want is a relation now between the velocity and the distance. I want to eliminate time here. So in order to do that, I can get time from here, and I'm going to plug in this equation, okay? So that's where it is. So let's see here. So from here, we find that time is going to be, I'm going to move V2 to the other side, right? It's going to be V minus V0, V minus V0 divided by the acceleration, okay? And now I'm going to plug in here in this equation, right? This is equation 1, this is equation 2, and now I'm going to plug the time in equation 2. So I'm going to have x0, I move x to the other side, so this is the delta x, this is delta x here, right? The difference between initial and final position, and v0 times v minus v0 divided by the acceleration, 1/2 a, and then v minus v0 squared divided by a squared. Okay? So now, what's going to happen now? Now, what do? I multiply v, right, inside the parentheses. So I can call this delta x. And here I'm going to have v0 v minus v0 squared divided by the acceleration. And here I can cancel 1a with a squared here. And I'm going to have plus 1/2 b minus v0 squared divided by a. All right? Yes.
When you substituted, why did you put a squared and one over there and a over here?
A squared and then a over here?
No, like you substituted and yeah, but you should. Should you put 8 squared when you substituted for 2? T. Sorry, you substituted for t.
T. Yeah, T is here. This is T. I put that here.
Yeah, but it's not.
He's saying you put the a squared down there and he squared the top.
Okay, cool. Sorry, the parentheses were confusing me.
So you want me to remove this and bring the parentheses like that?
That would make more sense to me.
That makes it easier for you?
Yeah.
That's okay. All right?
Yeah.
But this is going to be a squared,
Okay.
right?
Yeah.
And
when you
this
square
a.
it.
So I
Yeah.
can simplify that here.
Okay. Gotcha.
That's why I had it outside the parentheses.
Okay,
Is this okay now?
yeah.
All right, so now we need to solve this, right? This squared. What is this gonna be equal to? So if I have V0 squared,
It's gonna be v squared minus vo squared.
V squared minus
vo.
VO squared, is that it?
No, it's going to be v squared minus 2b v0 minus
Yeah,
v squared.
you cannot do that, right? That's a common mistake. Students forget that, the square is V0 times V0, right? And what is that you need to do here, the FOIL method? When you do that, you're gonna have V times V is V squared, V squared, minus V0 minus V0, right? And then plus V0 squared. So you see, I cannot just say V squared minus V0 squared. That's different. That's different than this here. Because I have this term here in the middle. See that? Gotta be careful with that. So this is V0, V squared, 2 times V0 plus V0 squared. There is this term here when I have V squared. Yes.
What's v0? Is it like the initial? What
Yeah,
is it?
V0 is the initial.
The initial, and then the other v is
It's the final.
the final.
The final velocity. Initial velocity, V0 means initial velocity at time 0. That's why we put V0. And then V is the final velocity. Okay? So all I'm going to do is I'm going to plug this in here. I'm going to plug this here. By the way, I didn't do this on the notes. So if you want, you can take a picture of this here so you don't forget. If you didn't understand where is this coming from, okay? You should know this from algebra, that A plus or minus B squared is going to be A squared plus or minus 2AB plus B squared. This is something you should know from algebra, right? How many of you don't recognize this? So now I'm going to continue here, okay? Can I erase this? So I want to write down here now. Okay, X V0 V minus V0 squared divided by A plus 1/2 is 0 all right.
Can we
Is
use
that
that?
good so far?
Can we use that equation to find the distance of the?
Excuse me?
Can we use that equation to find the change of distance for velocity, acceleration, and time if it's given?
Yeah, this equation you're going to be using when I, for instance, a problem that I have like a bullet that penetrates some object and goes deep so far. Like for instance, if I have here a wall and then I shoot and this bullet goes in here, it will come here with the initial velocity right before, and then it's going to penetrate so much. I'm gonna measure this, delta x. I know what is the final velocity here? What is the final velocity? The bullet penetrates 0, right? So v is 0. I'm gonna give you v, and I'm gonna ask you to calculate the acceleration, right? Deceleration, right? To stop. So this, how would you use this equation? This is the kind of problem you use that equation. Is that okay? No time involved. It's just velocities and acceleration. Is that okay? All right. So,
Professor,
yeah,
can you rewrite that? I can't understand the, like.
what, this one?
The second part.
This one?
Yeah, I can't read that.
Okay.
It looks like an N, but it's a V.
Yeah, I know, but it's like squished together, like, I really just, can you write a little bit bigger and like space it out a little bit more?
Yeah, it's because I need more space. Let's see if I can bring this down here. I'm trying to save space because, so I'm gonna rewrite this one here on the top. Is that okay?
Please.
Is that okay? So you all know where is this coming from, right? Is the square of v minus v0 is this. Okay? So now, I'm going to multiply both sides by 2a, okay? To eliminate the denominator here. The denominator on this side is 2a, the denominator here is a, okay? By doing that, I have now 2a delta x, and that is this side here, right? Now let's see if that side is going to be, end up to be v0 minus, v minus v0, okay? So here, because this is a, I'm going to have now 2 v0 v minus v0 squared plus v squared minus 2v v0 plus v0 squared. Okay? So the 2a is gone, and the a here is gone, but now I have this guy here. So this is going to be equal to 2 v0v minus 2 v0 squared plus v squared minus 2 v0 plus v0 squared. Okay? So you see that this guy is 2 v0v. This guy here is negative 2 v0, right?
Can cancel.
Commutative property, so this is the same as this one, so I can cancel this guy. Here I have v, so I'm going to have v here. And then here I have 2 v0 squared, and here I have, this is negative, and this is positive, so it's going to cancel. So I'm going to have negative v0 squared, and this is equal to 2a delta x. All right? So, in no way you're going to be asked on a quiz to do this, okay? you're gonna use the equation, but by learning how to do this, it's gonna help you to understand how things are going, okay? And also, helps to solve for different variables. So anything can be missing here, right? I need to give you information. Only one variable is going to be missing, so you can calculate the other one. So you need to learn how to solve for V0. I can give you the final speed and ask you to calculate V0 if I give you the acceleration and the distance. Is that okay? All right. So this ends what we started last week, the last class, and the handouts of last class. And we're going to start with the applications now of all those formulas that we solved for. So, and that involves a problem. Let's say this is, I have a golf ball. I hit the ball, and the ball is going with the initial velocity v0 at a certain angle alpha. That I know, that I measured. And then the question is, what is the shape of this trajectory? That is the first question. Okay? So what is the shape of this trajectory? Can we come up with an idea?
Whole trajectory or just where you marked at the initial velocity?
The whole trajectory, what is the shape of this trajectory?
Semicircle?
Yeah. Somebody else? A parabola, right? Parabola. Okay. All right. So if we try to manipulate these equations now and remove the time from them, and I have an equation of y and x describing this, I should have what kind of equation? Linear equation? A parabola is described by a linear equation or a quadratic equation, right? So that's what I want to try to show you now, that by solving this, we're going to, in terms of x and y, we're going to get a parabola. So the first step here is going to be to calculate the time here, right? So what is the value of x0? It's here, right? x0 is here. This is the x-axis. The value of x0 is 0. So we're going to get x0 equals to 0. Y0 is also 0, right? Y0 is also 0. What about the projection in the x-axis? What is the projection? I'm giving you here the velocity, v0, right? In a certain angle. Now, what is the projection on the x-axis? In terms of v0 and the angle, what is the projection? How much is this? V0x is equal to what?
The cosine of alpha.
Just the cosine of alpha? It's a projection, right?
There's a
V0
degree.
times V0 times
V
cosine alpha.
zero, V0 cosine alpha. Okay? Now, what is the projection? This is V0x. Now here I have V0y. What is V0y?
V0 sine alpha.
V0 sine alpha. Okay? All right, so let's, so from now, let's calculate, from this equation here, let's calculate the time with this being 0. So I have x as a function of time equals V0x, that is this here, that is V0 cosine alpha times t. So t is going to be x of t, V0 cosine alpha. Okay? All right? So if we want to have an equation of y in terms of x, so it's this equation here that we're looking for, y in terms of x, now we have to plug in this equation here, right? And eliminate the time and introduce x, all right? Is that, are you guys following me? Yes?
Yeah.
Can anybody say what I'm trying to do at this point?
Trying to plug in your value of t to eliminate it from that equation.
And show what? What is that I want to show?
You're trying to show the trajectory, I believe.
The trajectory is a parabola, right? And to show that, I just need to prove to you that that equation is a quadratic equation. And that's what I'm trying to do. Okay? So, so let's bring this here, and I'm going to erase this. Are you still able to read everything? Okay. Well, I hope this video really works so you guys can, you know, revisit this. If you didn't understand anything at this point, so now I'm going to rewrite this equation here. I'm going to eliminate y0 because that is equal to 0, and I'm going to substitute v0y. V0y is v0 sine of alpha. Okay, v0 sine of alpha times the time. The time is this guy here. Okay. That's the time. Now, what is AY?
Acceleration.
Huh?
Acceleration.
Is the acceleration. Yeah, but this thing here is flying, right? So what kind of acceleration is here?
Decreasing
It's pointing to where?
to the left.
It's pointing up? Is that what happened?
It's increasing, but it's slowly increasing.
The acceleration is increasing?
No.
The acceleration is changing at this point? Is the acceleration changing at this point, at this point, at this point? Has the acceleration changed?
Yeah. Because the rate at which it's going is slower.
I don't know.
So when I have something here, like let's say I throw this up, what is the acceleration that is
With zero, right?
what?
With zero?
Zero acceleration?
I don't know.
So what happened to this marker? I threw the marker up. The marker start with a certain speed, right? At the beginning was higher. The speed start reducing. What does that mean? If the speed is reducing, it's being accelerated, but is it being accelerated up or down? Down, because it is reducing, right? The speed is being reduced. So it's being deaccelerated, it's accelerated going in this direction. And what is that acceleration called?
Gravity.
Gravity, right? It's the acceleration of gravity. And then at some point, this body, or wherever, I send it up, stopped. And then start accelerating back down. So the acceleration is facing down. Now, this here is the same thing. Is the acceleration is, pushing this thing to go down, not to keep going up. If there were no acceleration here at all, what would happen to this golf ball? Let's say there's no acceleration here, there's no gravity. We're in complete space.
It would be a
It
linear
would keep going
function,
the
wouldn't
same.
What is
It
it?
would be a linear function, wouldn't it?
Would be a straight line. This golf ball would be going forever, right? Forever and ever. But because there is acceleration in this direction, right? This starts curving like that. And then goes to a full stop here when it hits the ground. How is that? Is that coming up? Is it becoming clear a little bit? I think it's because you missed last class.
Yeah.
That's why you're not following
Yeah.
on this one. We introduced acceleration last class with the experiment, right? So let's go back here. Now I'm talking about the y-axis. So y-axis is positive going up, right? So if the acceleration is pointing down, is that vector going to be, it is a vector, right? Acceleration is a vector, isn't it? Because, why? Why it is a vector?
It has a direction
It
and
has-
a magnitude.
It has a direction and a magnitude. Exactly. So, but it's negative. Now, the acceleration of gravity is g. What is the value of g?
9.81.
9.8 meters second, squared. So I'm gonna plug this number here now, but I'm gonna have to put a negative sign here, right? Negative sign, right? And this is gonna be 1/2, and then 9.8. And this is going to be the square now, right? The time square, this thing here. Is that okay? So x of t, v 0 squared, cosine squared. Okay? How's that? Is that coming up? So what do you see? Yes.
Didn't you say the gravity was gonna be negative since it was going up?
Yeah, you sent you the plus.
Yeah, that's why I put this negative sign. The negative sign is indicating that this thing is going down.
So the original equation, it was a plus 1/2 AY t squared, now it's minus 1/2.
This is the original equation. We came up with this equation last lecture, right? If you see the notes
Yeah,
You
but,
you don't have access to Canvas yet.
no, not yet, but my question was like, I saw the equation, but instead of putting the negative in front of 9.8, you put it in front of the negative, the 1/2. So I didn't understand
Because
that.
it's multiplied. So if you multiply 1/2 by negative 9.8, it's gonna be negative 9.8 over 2.
Well, you get a different number if you divide 9.8 by 1/2.
I've already put the negative sign in this.
But like, if you're multiplying like a positive and a negative together, the
It would
total-
be a negative,
It would be
but the
negative, so
number would be
that's-
different.
But the 9.8 is now positive, so he changed.
We always say
Yeah.
the acceleration is positive. We always say it's positive, okay?
I get that.
The value, the magnitude is always, we consider always positive. Now, we need to adjust, put the sign accordingly. If this thing is going down. it's-
Are we just doing the equation or we're not trying to solve it right now?
Yeah, well, I'm just showing, I just want to show that this is a quadratic equation. Now, when you look at this right now, do you visualize the quadratic equation or not? Okay, let's look at V0. Is V0 changing
Yes.
on the problem? V0 is changing? What is V0?
The initial velocity.
It's what?
The initial velocity.
Initial velocity, right? It started and boom, it's gone, right? V0 is here. This is V0. The velocity, the instantaneous velocity is changing. But I cannot change the past. I cannot change the date I was born. If I could, I would. I'd bring it up, you know? So I would be, instead of 62, I would be 22, you know? Right, isn't that good? Can we change V0? No, we cannot change the date we're born, right? Unfortunately, right? Unless it's a different problem, right? If it's a different problem, it's a different person, right? So this is constant. What about the angle alpha? Is that constant?
Yes.
Yes.
So it looks like all these guys here are constant, right? So I can rewrite this here. K1, this whole thing here is constant. X minus, what about here? This is a constant,
Yeah.
unless we comparing Earth with the moon, right?
No, that's
No,
different.
we're talking about the Earth. So this is also constant, so now I'm gonna have a K2X squared. So what does a quadratic equation looks like? It looks like this. YAX squared plus BX plus C. Is that something you recognize, right? So what is the shape of this one when A is positive? What is the parabola looks like? Yes? Looks like what? Like this? Yeah, that's how, you know. If you graph x squared, right? This is 0 here, then 1 squared is here, then 2 is 4, 3 is 9, and goes like that, right? Now, if I want to graph y equals negative x squared, what's going to happen? This graph is going to flip it down. So it's going to look like this, right? So we have a negative here. This is like A, right? The negative in front of the term with the x squared indicates that we have a maximum instead of a minimum, okay? Is that okay?
Is the K a kinetic energy?
Excuse me?
What is the K?
K, I'm just calling K a constant, this whole thing. When I plug in numbers here, just gonna be a number,
Yeah.
one constant. I'm just simplifying this equation so you can visualize. So I showed you that this here is a parabola.
Yeah.
That's all I did so far, okay?
One more question before we move on.
Yes?
So like if we're calculating, if we have the numbers and everything in that for that equation, and I'm still stuck on that situation, like the 1/2 times 9.8.
Or here?
Yeah, so if we're calculating, we're gonna have to actually multiply it, which is going to actually divide or whatever, and then that number is going to be negative, right? We can't just move around the signs.
Uh,
Yeah, right there. So it
You
was
talk about that this number is gonna be negative?
no.
When you calculate, what is gonna be negative?
So you know 1/2 is positive right there, and then
Yeah, it is
the gravity.
positive here.
Yeah, and then the gravity was negative, right? That's why you moved the sign, the negative,
Well,
to
the
1/2, right?
gravity is pointing
Down.
in this direction,
Yeah.
right? If the gravity were pointing in this direction, what do you think would happen to the trajectory?
I don't know. It would go like
Would go up,
Yeah.
you know, instead of the speed in the y direction decrease. You see, you have to isolate things. You have to isolate the speed in y. We have v0y, right? That is the initial speed on the y direction, from the v0x, that is the initial speed on the x direction, right? The speed on the y direction is changing because it's being affected by an acceleration. There is an acceleration, it's the gravity, right? Going in the y direction. But is there an acceleration in the x direction? Jade, what do you think? Jared, what do you think? Is there an acceleration in the x direction?
The initial
No.
acceleration? First
I
throw the
mean,
ball?
just accelerate. Well, the golf ball is gone, right? I never play golf, but I imagine, you know, you hold like this, something, and then you hit the ball, right? So the ball is going up. Now, once it's here, what's happening, you know? Is there an acceleration? We talk about gravity. Yeah, gravity is going down, but what about in the x direction? Is this projection being accelerated
Yes.
in the x direction?
Yes.
Where is this acceleration coming from?
The initial hit of the ball.
Well, it was initial, right? That was accelerated, and once it's out in space, I'm not touching the ball
It's
anymore.
not accelerated.
Huh?
The initial velocity is constant.
The initial velocity here is this one. The v0x is constant?
Yeah.
Yes. How many of you see that this velocity is going to be constant on the x direction? How many of you see that? You see that? Because there's no acceleration in this direction, right? So it shouldn't change. Remember, the speed, velocity changes if it's being accelerated. Remember the experiment with the cart? Was that being accelerated when I do my first punch on the cart? No, it goes at a linear motion, at a constant speed. There's no acceleration there. Now if I have this here and let it go, well, it starts from 0 and speeds up. Why? Because there is an acceleration in this direction. Why, when I let this thing go like this, why is not moving that direction?
because of gravity.
Huh?
Because of gravity. And
Because
the
there's
initial.
no force pushing this thing to go there. So there's no acceleration to the right or to the left. Look, it's just boom, straight down. Now, if I give a little touch, like that, Did you see? Was a parabola? Did you see? Was too fast? Isn't that a parabola? Look, it's a parabola, right? But once it's out, it's the same example I had with the cart here. When this thing is moving, it keeps moving at a constant speed in this direction. And there's no difference from this problem. Are you getting it? So please, if you still don't understand, let's have a dialogue about that, I want to hear what is going on in your mind, so we have a dialogue and we learn from that. I want to learn what are you thinking right now, so I can maybe explain a little better. Yes?
Okay, so the initial hit of the ball creates velocity, but not acceleration.
Well, don't try to, I don't know if that's what you're trying to do, is trying to memorize the situation. I want you to think, what's happening, well, ask yourself, okay? Once I hit, do you play golf? Once I hit the ball, or maybe, what's that thing that you guys, baseball? Or?
Just,
Yeah, the baseball, right? You throw the ball. Now, if you want to throw this ball really far away, what do? You throw with an angle, or you throw like this, straight?
With an angle.
With an angle, right? Do you know which angle would be the best?
The highest thing.
Huh?
The highest thing. I don't know.
45 degree?
Probably.
It's 45?
Yeah.
Who said that? The coach?
It just makes more sense.
It makes
If you throw
sense.
it too angled, it's just gonna fall sooner.
Yeah, if you go too high, it's gonna fall sooner. You want this thing to go high, so 45 degrees. So that's her instinct, she's been playing this, forever. She learned, and the first time she tried, this is too low, and the ball hit the ground sooner maybe, and then she's too high, or just go up and come down my head, so I need to find, a midpoint there, right? So she figured out that 45 is the best to go the farthest. Okay? Now, once I let that thing go, Henry, we know we have gravity, right? There's an acceleration. Is that acceleration changing as this ball is going through its trajectory? Is the acceleration changing?
Only in the y-axis, right?
Is the acceleration of Earth changing?
Oh, no, not the
No.
gravity.
It's the same, it's constant. What is changing here? The position is changing. What else is changing? The velocity in the y direction is changing. Do you see that? The velocity of y direction here starts at the highest. What is the velocity of the y direction here? At this point, at the peak?
0.
0. You see that? It's 0. At this point, the ball is not going up or down, right? It's kind of stopped going up, right? And start going what? Down, right? And start increasing again, just like this example that I let this thing go. Start from 0 and start to accelerating down, right? And then hits the ground. Is that exciting or not? I have goosebumps when I talk about these things. Okay. Should we move on or? Now the next question is, at what time is going to hit its maximum? How can we calculate that? what is the time that it's gonna take to hit this point?
You said it's like vertex.
Which equation are we going to use?
The third one.
This one? To calculate the time that it hits this point. We're discussing about the velocity on the y direction. What is the value of the velocity of the y direction at this point? 0, right? So I have this equation here. I know this is not changing. V0y is not changing. This is the projection here, is a constant. So I can figure the time if I set what? Velocity equal to? Huh?
The Y.
Vy.
I need to set this equal to 0 if I want to find the time. What is the time here? So from here, I can write that t is going to be equal to, well, again, we have here the acceleration, right? The acceleration is going in what direction?
Yeah.
This down, so it's gonna be negative. When this guy moves to this side, it's gonna be negative. So negative with negative, it goes away. Is that right? So, so I'm gonna plug in, let me rewrite this so you guys can get confused. I wanna rewrite it. Vy t equals V0y plus AT. Let's plug in the parameters that we describe, that describe this point, right? This is 0. This guy here is what? V0 sine alpha. V0 sine alpha. I'm gonna, this is AY, is G with negative GT. Now I need to calculate T. So I move this guy to this side, it's gonna be negative V0 sine alpha equals negative G. So T is gonna be V0 sine alpha divided by G. So that is the time it's going to take to be at this point. Okay? And what do we do with that? If now I want to calculate, I'm going to plug in here. Okay? I'm going to plug in here. So let's do that. Let's see. So I'm going to copy this equation again. Y t V0y t plus 1/2 a t squared. And I'm going to substitute this here, right? So when I do that, now what is y at that point? If you look here, y at that point is the height, h. So I'm going to plug in h there. Okay? Plug in h. Then V0 sine alpha times V0 sine alpha divided by G. minus 1/2, I'm continuing here, okay? Yeah. G V0 sine alpha G squared. Okay? So this is half of that, so I can just rewrite this thing. See, V0 times V0 is V squared. Sine alpha times sine alpha is square, so it's the same as this one here. So H is going to be 1/2 G V0 sine alpha squared. So what is this guy? What is H?
Hi.
Huh?
Height,
Height, but what kind of height?
the maximum height,
Is
the maximum
the
height.
maximum height, okay? H is the maximum height. Very good. Now, can you analyze this, this formula for me? What do you think? Is it reasonable that, so this is a fraction, right? If the numerator increases, what happens to the value of H? Increases, right? If the denominator increases, what happens to the
Decrease.
decreases, right? So acceleration, gravity, and Earth is G is 9.8. That's the Earth. On the Moon is what?
1.62.
1.62, right?
What is that for, the moon?
Yeah, the
That's for
gravity.
the
of the
Moon, yeah. So if we're talking about, if we're doing the same problem on the Moon, what's gonna happen to the height? Will increase, right? So what is the purpose of looking at these formulas is to, when you try to analyze the way I'm trying to direct you, you start having a better understanding of the physics involved, right? So what is physics? We're trying to describe, some movements, right? In this case here, the movement of a golf ball. And as you look at this equation, the equation is telling you what's going to happen. And as you look at this, well, if I increase V, what's going to happen to the height,
Okay, taller.
right? It's going to be higher and higher, right? So now you look at this problem here, and you have a much better understanding of what's going on in terms of the height, right? In terms of this height. Yes.
Can you show me how you got 2G as the denominator?
2G
Yes.
is because, look,
He will
uh,
just-
look this together, right? This is the equation. So I'm going to V0 squared, because V0 times this guy is V0, right, squared. Then I have sine squared divided by G. Okay? Now I have this side here. It's going to be negative 1/2. Now this guy here is going to be G squared. Divided, simplifying with this guy is going to be G, right? And this is going to be V0 squared sine alpha squared divided by G. Do you agree with me?
Yes.
So this is the same as this. So this is like 1 minus half is equal to half.
So shouldn't H be negative?
Negative?
Because you're saying it's 1 minus 1/2. Oh, never mind, just kidding.
It's 1.
A clicked.
Yeah, minus half is positive 1/2, right? It's not half minus 1. If we're half minus 1 would be negative half, right? It's like 5 minus 3 and 3 minus 5. Is that okay?
Yeah.
So, we still have time. Now, we have, what is it? Behind here, at some point, we have calculated the time to reach this point. Can anybody tell me what is going to be the time to reach the ground? Tell me, what do you think? The time to reach the highest point is this.
So that times
Is what?
2, that times 2.
That's times 2. Exactly. Why? Because this parabola is what? Symmetrical. So the time that takes to come here is going to be the same time that it's going to take there. So we just multiply that by 2. Excellent. So now, what if I want to calculate, I want this is going to be a homework. Okay? Homework. Calculate this distance here. Find the formula for this distance. What are you going to do? First, you have this time, right? The time to be here is going to be 2t. 2t is this. 2 times this value. What are you going to do with this? If you want to calculate this distance, you want to calculate OS. You have the time. What else do you have?
The initial.
You have this equation here, right? What are you going to do?
Okay.
Plug in what? The time 2t, right? Plug that in here, substitute v0y, and then you're going to have this distance. Is that okay?
Can we use the first equation?
Hmm?
Can we use the first equation too?
This one?
Yeah,
Um,
because we have almost everything in that.
yeah, you can use the first equation.
Okay.
So you have x x0 plus v0xt. So the time is t equals 2xt divided by v0 cosine alpha. You plug that in here. You plug this guy here. Vx0 is v0 cosine alpha. Then x minus x0 is this distance, right? Then you have. The answer should be OS is going to be v0 squared sine alpha, sine 2 alpha divided by g. Okay? On the notes, I put it down some trigonometric formulas here. The sine of A plus B is equal to sine of A cosine B plus cosine A sine B. So the sine of 2 alpha is going to be 2 sine alpha cosine alpha. So you're going to have to use this form. So I'm going to post this on Canvas, and I'd like you to redo this calculation step by step to see if you understand this whole thing. I also posted already a file on trigonometric functions. We have all these formulas. And like I said, as the class progresses, you should be building your table with all the formulas, right? The basic formulas, right? The basic formulas, those ones, okay? Not this one, not this form. This is not to be on your table, all right? So prepare that table for Tuesday. Yeah, you can turn off the, did you turn it on?